All right, so we're going to take a look at some special quadrilaterals here that we've already learned about and see what happens. So this first example says that we have quadrilateral ABCD, and there are at least two congruent sides, consecutive congruent sides. So two sides in a row that are congruent. What quadrilaterals meet this condition? So here's a possibility, two congruent sides in a row. So what other quadrilaterals? Now we can move this, we can change this angle right here. So if you think about it, what possibilities could we have? So it might be helpful to just think of all of them. So the first one would be a parallelogram. So could it be a parallelogram? So could this side be parallel to that side and this side be parallel to that side? Well, yeah. But if it was a parallelogram, then let's be more specific. So let's go with the most specific name possible. So if these two sides were equal and it was a parallelogram, in a parallelogram the opposite sides are equal, that would mean all four sides were equal, and that would mean it was a rhombus. Okay? So I'm trying to limit my answers as specifically as possible. So if I have a rhombus, I know a rhombus is a type of parallelogram. So I don't need to say parallelogram necessarily. It depends on the instructions. But let's just say that rhombus implies parallelogram, so that's all we need there. Now, what if we took that rhombus? It could be a rhombus. The thing is, it can't be a parallelogram without being at least a rhombus. So that's why we don't need to put that. But what if we put a right angle right here and then did that? That would make it a what? Yeah, a square. Good job. So it would be a square. Okay? So it could be a square or a rhombus. Now, a square is a type of rhombus, but the point is it doesn't have to be a square. It could be a rhombus and not be a square. But it couldn't be, in this situation, it couldn't be a parallelogram and not be a rhombus. It's a little bit tricky. Okay, what else could it be? Well, if we do that, and we bring this down here, and we do it across there, we could make a kite. So hopefully you see that we could make a kite out of that as well. Now, if we made a side parallel to that, then we could make a trapezoid. Okay, so is there anything else we could make? What if got this down here like that? That would be an isosceles. Isosceles trapezoid. All right. So looks like that might be about it. So there's 5 different things that it could be. Okay. If this lesson gives you a hard time, it's not that big of a deal. So don't stress about it too much. Just try to get through these notes and see what you can come up with. So when you join the midpoints of the sides of any quadrilateral, you get a parallelogram. That's in our book example 2 in this section. So any quadrilateral, if you connect the midpoints, you get a parallelogram. When you join the midpoints of the sides of an isosceles trapezoid, what do you get there? Okay, so let's see. Isosceles trapezoid. All right. Isosceles trapezoid. Let's see how I do here. Might have, maybe I should have made that bigger, but I'll see how it goes. Probably should have made it bigger. All right, so It says join the midpoints of this in order. So all right. So if we connect these in order, what does that look like? Well, we just said that any quadrilateral, if you connect the midpoints, you get a parallelogram. That means this is a parallelogram already. So that means these two sides are congruent and these two sides are congruent. So we know that. Now, opposite sides of the parallelogram are congruent. Okay. Now what? Well, join the midpoints. So if this is a midpoint, that means these two are equal. And if it's isosceles, that means this side is equal to this side. So that means these are equal also. And this was a midpoint, so that means those are equal also. And if this is an isosceles trapezoid, that means that that is equal to that. So by side angle side congruence, we have congruent triangles here and here. And then we can use CPCTC to say that this side is congruent to that side. Okay? So, and we know it's a parallelogram, so opposite sides are congruent, so we know that that side's congruent to that side. So, for congruent sides, and that means it's going to be a rhombus. Okay. So, the coordinates of quadrilateral ABCD are given by those four coordinates, show that it is a rhombus. So, to show that it's a rhombus, we could show that it has four equal sides, and so we could find the lengths of the four sides. So we could say A to B. And again, anytime you can pause and try something yourself, so if you pause that and try to figure that out, how to start that, and then you could play it to see if you're right and see if you want to do that or not. So x minus x squared plus y minus y squared. So that's going to be negative 3 squared is 9, and negative 3 squared is 9. So that's 2 9s. So I could just put 9 times 2. All right? Now you could say that's 18, and then you could factor 18 to 9 and 2. But so that's 3 root 2. Now I'm going to do BC, which would be the next side. So BC, that's going to be 1 minus 4 squared plus 8 minus 5 squared. Well, I hope we all see pretty quickly. That's a 1. That's negative 3 squared. That's 9 and 9. So we get 9 and 9 again. So that's going to be 3 root 2. I really need to do that workout again. So CD. So that's going to be 4 minus 1 squared and 5 minus 2 squared, and again 3 root 2. And finally, DA. If I was going in alphabetical order, I would have said AD and I would have put it up there. But so DA, D, 1 minus a negative 2 squared and 2 minus 5 squared So that's 3 squared is 9, negative 3 squared is 9, so same thing. Okay, so we have 4 equal sides. So by the definition of congruent, we have 4 congruent sides, and then that means we have a rhombus. So two rhombuses in a row. Okay, next. In quadrilateral RSTV, R is 88, S is 113, and V is 113. So, R is 88, S is 113, and V is 113. So we have two opposite angles that are congruent. So what might that look like? So let's find out. So I'm going to start with R on top here, and that's about 88 degrees. So if I do this, that would be 90, so a little bit more than that. So I guess I could have paused while I was thinking about that. I have this other diagonal down here. So I think I drew that very well. Okay. So R is 88. I'm going to put R up here, and then S, T, V, and S and V were both 113. So those are congruent. All right. So that we got 113, 113, and 88. So we could add those all together and subtract from 360, and that would give us this one down here. So that looks like a kite. It could be a kite. Does it have to be a kite? So this is 226 and 88. So that's 314. So 360 minus 314 is, now I got to borrow off of there, 46. One of the things you can do to check arithmetic, like I added that back together and it didn't add up, so 46. So T is 46. So no consecutive angles are supplementary. So it can't be a parallelogram or any of the family of parallelograms, squares, circle, a square, circle, square, rectangle, rhombus. So it can't be any of those. So that kind of just leaves us with a trapezoid or just a regular quadrilateral. It can't be a trapezoid because none of those sides will be parallel, because if two of those sides were parallel, then we would have a supplementary as well. So there's no parallel. Does it have to be a kite? So does it have to be a kite is our question. Well, if you think about it, if I slide this side up this way some, I could keep those angles the same size if I put a parallel. So that is the same as that still, and this would be the same as this still if I moved it up parallel. And now these two aren't congruent, so now it's not a kite. So does it have to be a kite? No. And that drawing is the explanation. All right. All right, so that's a bit awkward. We're almost done here. Then we're going to review a little bit, a couple questions. So let's see what we have to do on this one. The diagonals of A, B, C intersect at point N to form four congruent isosceles triangles. So what type of quadrilateral is it? Prove your answer is correct. Okay, four congruent isosceles triangles. All right, I'm not sure what this looks like, so I'm going to just draw something and start labeling it up. So I'm going to go with that. Who's that? All right, so the diagonals of quadrilateral A, B, C, D intersect at point N to form four congruent isosceles triangles. So first of all, these are all isosceles, which means they all have two equal sides. So that, and that. Okay. And here, if we look at this, since these triangles are all congruent, AB and BC, AB and BC, and CD and AD are all congruent also. Because if those triangles are all congruent by CPCTC, okay, so isosceles, that gave us the congruent, or the diagonals bisect, would be better. Diagonals bisect. Okay. And we can see from that the diagonals are going to be congruent also. So if the diagonals are congruent, that means it's a rectangle. The diagonals bisect each other. That means it's a parallelogram. And here, by CPCTC, we have the four congruent sides, which means it's a rhombus. So if it's a rhombus and a rectangle, that means it's a square. Alright, so like I said, if that's a little bit stressful, if you're not really, that's not that important. Now this review question here, this is important. It's got some algebra in it. Anytime we do algebra, that's really important. We're trying to help you for next year. So this is find all the possible values given the trapezoid. So these are trapezoids, and that's a mid-segment. So what you're supposed to remember is that the mid-segment is the average of the other two. It should be kind of obvious. If we add these together and divide by 2, we get that. So that's going to be x squared plus 10 plus 8 minus x over 2 equals 4x. Now again, I could have said pause. You could pause it now and you should be able to do that. I'm going to multiply both sides by 2. I'm going to add those two together. Those are like terms. I should have put the negative x in the middle, but I'll take care of that this time. So we multiply by 2, that's going to be 8x. So this is going to be x squared. If we subtract, it's going to be minus 9x plus 18. Okay? So if we factor that, that's going to be x and x. Now this is positive. That means these both need to be negative to get that negative in the middle. So we need two factors of 18 that add up to 9. 1 and 18, no. 2 and 9, no. 3 and 6, yes. So x either needs to be 3 or 6. So if you come back up here and check, see, does that work? Is that okay? So 3, that would be 5, 12, and 19. That seems to be okay. 6, that would be 2, 24, and 46. That seems to be okay. All right. So now you should definitely be able to pause this and try that yourself. We just showed you what to do. You should be able to do the same thing. And you should try to cover this one up and just try to do it from your brain. Okay. Alright, so rearrange that a little bit. Multiply both sides by 2. That'll cancel this 2 out down here. Don't just try to cancel that 2 off with those. If they all had a 2 in them, then we could cancel that out, but not here. So times 2. Now subtract that over here. Add 2 to both sides. Now that's a GCF. We're going to factor out the GCS. That's going to be x times x minus 4. So x either equals 0 or x equals 4. Now 0 is not going to work. If you plug 0 back in there, then that's 0, that's negative 1, that's negative 2. That doesn't make sense. But if you plug in 4, you're okay. Alright, so pause, cover this up. You can cover that up with a piece of paper. Just put a piece of paper over these like that. And then you can work on this problem here. So the average of the top and the bottom equals the middle. The average of the top and the bottom equals the middle. Okay? So multiply that side by 2. Subtract that over here, so that's going to be x squared minus 12x. Add 16 to both sides. Be careful. It's a good idea to show that step so you don't get confused there. And we're going to try to factor that. It's going to be x and x. And that's positive, so these have to have the same sign, and it's negative here, so they need to be negative. So I need 2 factors of 32 that add up to 12. Hopefully you can find those fairly quickly. 4 and 8, 4 and 8. And let's see. If we plug 4 in here, we get 16 and 6. They're all 16. Well, that's not going to be a trapezoid. If all 3 of those are 16, can't be a trapezoid. So that's why we're going to eliminate that answer. So the answer is going to be 8. Okay. Construct a regular hexagon. So regular means all the sides are equal. When I use a compass, if any of you actually have a compass, I turn it to the side, and usually I move the paper more than I move the compass. And that usually works for me better. So I turn it to the side, like when you write with a pen, pencil, you have it at an angle, you hold it at an angle, you don't right straight up and down, hopefully. All right. Then what you're going to do is you're going to keep that radius. You're going to move it out to the circle, and you're going to make arcs. You're going to work your way across, and then you move the compass up to the next point that crosses, and you make another one, and then you move your compass up to that point. If you don't have a compass, just fake it. It's not that important. We're almost done here. So now I can just connect those, and it should make a regular hexagon. Remember, regular means that all the angles are equal and all the sides are equal. So we also could actually use that to make an equilateral triangle, although we have a faster way to make an equilateral triangle. So I missed there a little bit. This might look a little lopsided. Hopefully. All right, and so those are all equal, so that's the equilateral hexagon. It's about that time. Have a good day. I'm wearing an AP shirt that the students made a long time ago. So there's the magic 5 on this side. Wait, this side over here. Okay. So I talk about the magic 5 in my class a lot, so you guys know what I'm talking about. 5 is the highest score you can get on an AP test. So they made it. They put the AP test on there, so it's like a concert shirt. So anyway, it's about that time. Have a good day. What happened? Where am I?